this video, we'll look at factoring quadratic trinomials, and specifically we'll look at two types that are kind of like special types, or I guess maybe three types. But the first type is usually a lot of times what people learn to factor first for trinomials, where instead of there being a number in front of x squared, it's just an x squared. So I have the video right before this that I posted is where if you have a number in front of x squared, how you can go about solving that, if you need to check that out. And then we have some special products that are, if we can recognize a pattern and use that pattern, then it will make them a little bit easier to factor. So remember that when we factor, we are trying to come up with two things that multiply together to get what we start with. And so just like when we had a number in front of x squared, this split up into two parentheses, the same thing is going to happen here. We are going to say, since there's not a number in front and sliding the one that's in front doesn't actually change anything, what we really want to do is go back to the idea of x squared has to split up into the beginning of this of each parentheses, and the only way to split up x squared is x and x. And 6 has to split up into the end of each parentheses, but it has to do that in such a way that these outside and inside terms will add together and give you the 5. So what we're doing is we're looking for what multiplies to get 6 and adds to get 5. So if necessary, we can make a list of factors out to the side. For a number like 6, where it's pretty small and easy to come up with, you may not need to make a list, but that's always like a fallback for me, is that if I don't immediately think of what works, I make a list of the factors, because then we can say, okay, 1 plus 6 is 7, that's not it. 2 plus 3 is 5. All right, we figured it out. So since this is positive and this is positive, we want both of these to be positive. So that our answer is x plus 2 and x plus 3. Those can go in the reverse order. You can have x plus 3 first and x plus 2 second. And we can always check our answer by foiling or using the distributive property to see if we get what we started with. So you should, if you already looked at the previous video or already did problems where there's a number in front of x squared, we should find these to be quite a bit easier because there's not a number in front of x squared. It actually takes out a couple steps in our problem. So we're just going to do a few more examples of that and then move on to the special products. So here I'm looking for what multiplies to get 15 and adds to get -8. A note on this is that if it needs to multiply to get 15, they either both have to be positive or both negative. And since I want to add and get a negative number, that means they should both be negative. So I personally, when I make my list of factors, don't usually put negatives at the beginning, but then I could afterwards, I could say, okay, well, they both need to be negative. So do I want -1 minus 15, or do I want -3 minus 5? And I definitely want the second one. So in our parentheses, we're going to have x minus 3 and x minus 5. And that's our answer. All right, so this is a case where this number 72, that's quite a bit bigger and has a lot more factors. It may be that you immediately think of the correct factors and just get this really quick, but usually if we don't get it right away, it can be really hard for us to come up with the factors word, and I think I said this in the last video as well. So if you're having problems thinking of factors of 72, the best thing to do is be really methodical. Start with 1. 1 times 72 is 72. Then see if 2 divides in, which it does. 2 times 36. And you can check as you go to see if what you're getting works. Since this is negative, one of these will be negative, so we're trying to see what subtracts to get 21. 3 divides and goes in 24 times. Oh, and if I subtract those, I get 21. So the question is, do I want 3 minus 24, or do I want 24 minus 3? Which of those gives me a positive 21, which is this second one here. So the bigger number needs to be positive in order to make this positive. So we have x plus 24 and x minus 3. And that's our answer. Now let's look at some special cases. So in some ways, we don't really have to treat these as anything special. Like I can say, okay, this, if I wanted to multiply to get 9 and add to get 6, then I would do 3 and 3. But the reason that this is special is because I could rewrite this as x plus 3 squared, because it's the same thing twice. And then I can actually get this by saying, if I can square root both of these outside numbers, which I can, the square root of x squared is just x, and the square root of 9 is just 3. And this plus sign right here would put a plus sign in the middle. If I can do that, then I can get to this answer more quickly. Now, for this problem, that was not difficult to do. But now let's look at this one. If I want to do this without using this special pattern, then I'm going to have to slide and divide. And 25 times 49 is a really big number, and it's going to be really difficult to come up with the correct factors. But if instead I say, hey, wait, I can take the square root of 25x squared and get 5x. I can take the square root of 49 and get 7. And then I look at this sign, and if it's positive, I put plus. If it's negative, I put minus. And then I just have to say, okay, it's this squared. Then if we can come up, if we can use that pattern, that will be super helpful. It may be that either we just never encounter numbers quite that big, or that it just works out to be easier. So we may not have to use the pattern, but it is helpful that whenever you see these things that you can square root, that it should kind of click in your head that, oh, something special is going on here. The other pattern is when I actually don't have a middle term. So not having the C term will end up being different. But if I don't have that middle term that has, in this case, it should have had an x, or in this case, it should have an xy, then what's happening here is that we could say, well, if there's not a middle term, it's like I'm trying to add to get 0. So what multiplies to get negative 10, but adds to get 0? So that would have to be negative 10 and positive 10. This is also a pattern. And so we looked at it when we were multiplying polynomial or binomials together. So if there's not a middle term, and this is subtraction in the middle, then all you have to do is, like on the last problem, is square root this and square root this, and then put different signs. So here, where we've got something more complicated, where if we wanted to try to figure this out without using the pattern, we'd need to use like slide and divide. All we have to do is say, I can square root this, I can square root this, and put a plus sign in one parentheses and a minus sign in the other, and it doesn't matter which order you do that in. So I've done that in opposite orders between these two problems. And if you're in any doubt that what we did is actually correct, then FOIL this out or distribute this out. 9x and 9x is 81x squared. 9x and negative 11y is negative 99xy. And then these middle terms make positive 99xy. So they cancel each other out, which is why we don't have a middle term. So if you see problems like this where it's like, man, that's going to really be frustrating to have to solve out, one of the things you should probably do is check to see, can I divide everything by the same number? Because that can make things easier. But then also, if there's something you can square root, chances are you can use one of these patterns. And that will make things easier for you as well. So this has been factoring special products with trinomials, or quadratic polynomials in general, and then also factoring where there's not a number in front of x squared.